Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Balloon. A balloon is a flexible membrane bag that can be inflated with a gas, such as helium, hydrogen, nitrous oxide, oxygen, or air. For special purposes, balloons can be filled with smoke, liquid water, granular media, e.g., sand, flour, or rice, or light sources. Modern day balloons are made from materials such as rubber, latex, polychloroprene, or a nylon fabric, and can come in many different colors. Some balloons are used for decorative purposes or entertaining purposes, while others are used for practical purposes such as meteorology, medical treatment, military defense, or transportation. A balloon's properties, including its low density and low cost, have led to a wide range of applications. The rubber balloon was invented by Michael Faraday in 1824 during experiments with various gases. He invented them for use in the lab. Balloons are used for decorating birthday parties, weddings, corporate functions, school events, and for other festive gatherings. The artists who use the round balloons to build are called stackers, and the artists who use pencil balloons to build are called twisters. Most commonly associated with helium balloon decor, more recently balloon decorators have been moving towards the creation of air-filled balloon decorations due to the non-renewable natural resource of helium limited in supply. The most common types of balloon decor include arches, columns, centerpieces, balloon drops, sculptures, and balloon bouquets. With the increased aptitude for balloon twisting as well as balloon stacking, the rise of the deco twister manifests itself as a combination of stacking techniques, as well as twisting techniques to create unique and interesting balloon decor options. Party balloons are mostly made of a natural latex tapped from rubber trees and can be filled with air, helium, water, or any other suitable liquid or gas. The rubber's elasticity makes the volume adjustable. Often the term party balloon will refer to a twisting balloon or pencil balloon. These balloons are manipulated to create shapes and figures for parties and events, typically along with entertainment. Filling the balloon with air can be done with the mouth, a manual or electric inflator such as a hand pump, or with a source of compressed gas. When rubber or plastic balloons are filled with helium so that they float, they typically retain their buoyancy for only a day or so, sometimes longer. The enclosed helium atoms escape through small pores in the latex, which are larger than the helium atoms. However, some types of balloons are labeled helium grade. These balloons are often thicker and have less porosity. Balloons filled with air usually hold their size and shape much longer, sometimes for up to a week. However, a rubber balloon eventually loses gas to the outside. The process by which a substance or solute migrates from a region of high concentration through a barrier or membrane to a region of lower concentration is called diffusion. The inside of balloons can be treated with a special gel, for instance, the polymer solution sold under the High Float brand, which coats the inside of the balloon to reduce the helium leakage, thus increasing float time for a week or longer. Beginning in the late 1970s, some more expensive and longer-lasting foil balloons made of thin, unstretchable, less permeable metallized films such as mylar started being produced. These balloons have attractive, shiny, reflective surfaces and are often printed with color pictures and patterns for gifts and parties. The most important attributes of metallized nylon for balloons are its light weight, increasing buoyancy, and its ability to keep the helium gas from escaping for several weeks. Foil balloons have been criticized for interfering with power lines. Balloon artists are entertainers who twist and tie inflated tubular balloons into sculptures, such as animals. The balloons used for sculpture are made of extra stretchy rubber so that they can be twisted and tied without bursting. Since the pressure required to inflate a balloon is inversely proportional to the diameter of the balloon, these tiny tubular balloons are extremely hard to inflate initially. A pump is usually used to inflate these balloons. Decorators may use helium balloons to create balloon sculptures. Usually, the round shape of the balloon restricts these to simple arches or walls, but on occasion, more ambitious sculptures have been attempted. It is also common to use balloons as table decorations for celebratory events. Balloons can sometimes be modeled to form shapes of animals. Table decorations normally appear with 3 or 5 balloons on each bouquet. Ribbon is curled and added with a weight to keep the balloons from floating away. A decorative use for balloons is in balloon drops. In a balloon drop, a plastic bag or net filled with air-inflated balloons is suspended from a fixed height. Once released, the balloons fall onto their target area below. Balloon drops are commonly performed at New Year's Eve celebrations and at political rallies and conventions, but may also be performed at celebrations including graduations and weddings. For decades, people have also celebrated with balloon releases. This practice has been discouraged by the balloon industry as it has posed problematic for the environment in cities. In recent years, legislation such as the California Balloon Law has been enacted to enforce consumers and retailers to tether helium-filled foil balloons with a balloon weight. This ensures that the helium-filled balloons do not float into the atmosphere, which is potentially injurious to animals, the environment, and power lines. Many states now have banned balloon releases. It is becoming more common for balloons to be filled with air instead of helium, as air-filled balloons will not release into the atmosphere or deplete the earthly helium supply. There are numerous party games and school-related activities that can use air-filled balloons as opposed to helium balloons. When age appropriate, these activities often include the added fun of blowing the balloons up. In many events, the balloons will contain prizes, and partygoers can pop the balloons to retrieve the items inside. Balloons are used for publicity at major events. Screen printing processes can be used to print designs and company logos onto the balloons. Custom-built printers inflate the balloons and apply ink with elastic qualities through a silk screen template. In January 2008, the Jewish Community Relations Council of New York organized a display of 4,200 red balloons outside the United Nations headquarters. Also, in the 1950s, at the start of the Cold War, activists in Western Europe used balloons for propaganda purposes that would float east over Eastern Europe, which would release newspapers and pamphlets. In 2014, South Korea activists used the same balloon method to get information to those in North Korea. Paolo Scannanivo set the record of 11 for the most giant balloons entered in 2 minutes. Water balloons are thin, small rubber balloons filled with a liquid, usually water instead of a gas, and intended to be easily broken. They are usually used by children who throw them at each other, trying to get each other wet as a game, competition, or practical joke. By forcing water out the open end of a water balloon, it is possible to use it as a makeshift water gun. Solar balloons are thin, large balloons filled with air that is heated by the sun in order to decrease its density to obtain lift. Balloons are often deliberately released, creating a so-called balloon rocket. Balloon rockets work because the elastic balloons contract on the air within them, and so when the mouth of the balloon is open, the gas within the balloon is expelled out, and due to Newton's third law of motion, the balloon is propelled forward. This is the same way that a rocket works. Balloons filled with hot air or a buoyant gas have been used as flying machines since the 18th century. The earliest flights were made with hot air balloons using air heated with a flame, or hydrogen as the lifting gas. Later, coal gas, and later still, helium were used. An unpowered balloon travels with the wind. A balloon which has an engine to propel it is called a dirigible balloon or airship. Angioplasty is a surgical procedure in which very small balloons are inserted into blocked or partially blocked blood vessels near the heart. Once in place, the balloon is inflated to clear or compress arterial plaque and to stretch the walls of the vessel, thus preventing myocardial infarction. A small stent can be inserted at the angioplasty site to keep the vessel open after the balloon's removal. By the 18th century, people were inflating balloons of cloth or canvas with hot air and sending it aloft. The Montgolfier brothers going so far as to experiment with first animals in 1782, and then when altitude did not kill them, human beings in 1783. The first hydrogen-filled gas balloon was flown in the 1790s. A century later, the first hydrogen-filled weather balloons were launched in France. The first modern rubber balloons on record were made by Michael Faraday in 1824. He used these to contain gases he was experimenting with, especially hydrogen. By 1825, similar balloons were being sold by Thomas Hancock, but like Faraday's, they came disassembled as two circles of soft rubber. The user was expected to lay the circles one on top of the other and rub their edges until the soft, gummy rubber stuck, leaving the powdered inner part loose for inflation. Modern pre-assembled balloons were being sold in the US by the early 20th century. Traditionally, balloons are manufactured from plastic. With the rise of worldwide awareness for environmental conservation, some balloon manufacturers started making balloons out of biodegradable materials, which are made entirely of natural recyclable rubber trees. These balloons manufacturing processes preserve the natural state of the material in such a way that allows it to degrade relatively quickly. Some of the manufacturers only use rubber trees that are grown in plantations that receive the Rainforest Alliance's approval and at which its representatives conduct regular inspections in order to make sure that the farmers meet several criteria set to ascertain that the biological diversity in the area is maintained, and that no worker or natural resource is abused in the material manufacturing process. Once inflated with regular atmospheric air, The air inside the balloon will have a greater air pressure than the original atmospheric air pressure. Air pressure technically is a measurement of the amount of collisions against a surface at any time. In the case of a balloon, it measures how many particles collide with the wall of the balloon and bounce off at any given moment. Since this is nearly impossible to measure, air pressure seems to be more easily described as density. The similarity comes from the idea that when there are more molecules in the same space, more of them will be heading towards a collision course with the wall. The first concept of air pressure within a balloon that is necessary to know is that air pressures try to even out. With all the bouncing against the balloon wall, both interior and exterior, there will be a certain amount of expansion and contraction. As air pressure itself is a description of the total forces against an object, each of these forces on the outside of the balloon causes the balloon to contract a tiny bit, while the inside forces cause the balloon to expand. With this knowledge, one would immediately assume that a balloon with high air pressure inside would expand based on the high amount of internal forces, and vice versa. This would make the inside and outside air pressures equal. Balloons have a certain elasticity to them that needs to be taken into account. The act of stretching a balloon fills it with potential energy. When it is released, the potential energy is converted to kinetic energy, and the balloon snaps back into its original position, though perhaps a little stretched out. When a balloon is filled with air, the balloon is being stretched. While the elasticity of the balloon causes tension that would have the balloon collapse, it is also being pushed back out by the constant bouncing of the internal air molecules. The internal air has to exert force not only to counteract the external air to keep the air pressures even, but it also has to counteract the natural contraction of the balloon. Therefore, it requires more air pressure or force than the air outside the balloon wall. Because of this, when helium balloons are left and they float higher as atmospheric pressure decreases, the air inside it exerts more pressure than outside it, so the balloon pops from tension. In some cases, the helium leaks out from pores and the balloon deflates, falling down. High altitude balloons or stratostats are usually uncrewed balloons, typically filled with helium or hydrogen, and released into the stratosphere, generally attaining between 18 and 37 kilometers above sea level. In 2013, a balloon named BS 13-08 reached a record altitude of 53.7 kilometers. The most common type of high altitude balloons are weather balloons. Other purposes include use as a platform for experiments in the upper atmosphere. Modern balloons generally contain electronic equipment, such as radio transmitters, cameras, or satellite navigation systems, such as GPS receivers. Hobbyists frequently purchase weather balloons because of their ease of use, low price point, and widespread commoditization. These balloons are launched into what is defined as near space, defined as the area of Earth's atmosphere between the Armstrong limit, where pressure falls to the point that a human being cannot survive without a pressurized suit, and the Kármán line, where astrodynamics must take over from aerodynamics in order to maintain flight. Due to the low cost of GPS and communications equipment, high altitude ballooning is a popular hobby, with organizations such as UKHAS assisting the development of payloads. In France, during 1783, the first public experiment with hydrogen-filled balloons involved Jacques Charles, a French professor of physics, and the Robert brothers, renowned constructors of physics instruments. Charles provided large quantities of hydrogen, which had only been produced in small quantities previously, by mixing 540 kilograms of iron and 270 kilograms of sulfuric acid. The balloon took 5 days to fill and was launched from Champ de Mars in Paris, where 300,000 people gathered to watch the spectacle. The balloon was launched and rose through the clouds. The expansion of the gas caused the balloon to tear, and it descended 45 minutes later, 20 kilometers away from Paris. Crude high-altitude balloons have been used since the 1930s for research and in seeking flight altitude records, including Auguste Piccard's flights up to 16,201 meters, the Soviet Osovyagin-1 at 22,000 meters, and the American Explorer 2 at 22,066 meters. Notable crude high-altitude balloon flights include 3 records set for highest skydive. The first set by Joseph Kittinger in 1960 at 31,300 meters for Project Excelsior, followed by Felix Baumgartner in 2012 at 38,969 meters for Red Bull Stratos. Most recently, Alan Eustace in 2014 at 41,419 meters. Uncrewed high-altitude balloons are used as research balloons for educational purposes and by hobbyists. Common uses include meteorology, atmospheric and climate research, collection of imagery from near space, amateur radio applications, and submillimeter astronomy. High-altitude balloons have been considered for use in telecommunications and space tourism. Private companies such as Zero to Infinity, Space Perspective, Zefalto, and Worldview Enterprises are developing both crewed and uncrewed high-altitude balloons for scientific research, commercial purposes, and space tourism. High-altitude platform stations have been proposed for applications such as communications relays. In many countries, the bureaucratic overhead required for high-altitude balloon launches is minimal, and the payload is below a certain weight threshold, typically on the order of a few kilograms. This makes the process of launching these small HABs accessible to many students and amateur groups. Despite their smaller size, these HABs still often ascend to and past altitudes on the order of 30,000 meters, providing easy stratospheric access for scientific and educational purposes. These amateur balloon flights are often informed in their operations by the use of a path predictor. Before launch, weather forecasts containing predicted wind vectors are used to numerically propagate a simulated HAB along a trajectory, predicting where the actual balloon will travel. Testing radio range is often a large component of these hobbies. Amateur radio is often used with packet radio to communicate with 1200 baud, using a system called Atomic Packet Reporting System back to the ground station. Smaller packets, called micro or pico trackers, are also built and run under smaller balloons. These smaller trackers have used Morse code, field hell, and RTTY to transmit their locations and other data. The first recorded amateur radio high-altitude balloon launches took place in Finland by the Ilmari program on May 28, 1967, and in Germany in 1964. Amateur radio high altitude ballooning, RHAB, is the application of analog and digital amateur radio to weather balloons, and was the name suggested by Ralph Wallio. Often referred to as the poor man's space program, RHAB allows amateurs to design functioning models of spacecraft and launch them into a space-like environment. Bill Brown is considered to have begun the modern RHAB movement with his first launch of a balloon carrying an amateur radio transmitter on the 15th of August, 1987. An RHAB flight consists of a balloon, a recovery parachute, and a payload of one or more packages. The payload normally contains an amateur radio transmitter that permits tracking of the flight to its landing for recovery. Most flights use an automatic packet reporting system, APRS tracker, which gets its position from a global positioning system, GPS, receiver, and converts it to a digital radio transmission. Other flights may use an analog beacon and are tracked using radio direction finding techniques. Long-duration flights frequently must use high-frequency custom-built transmitters and slow data protocols such as radio teletype, RTTY, Hellschreiber, Morse code, and PSK31 to transmit data over great distances using little battery power. The use of amateur radio transmitters on an RHAB flight requires an amateur radio license, but non-amateur radio transmitters are possible to use without a license. In addition to the tracking equipment, other payload components may include sensors, data loggers, cameras, amateur television, ATV transmitters, or other scientific instruments. Some RHAB flights carry a simplified payload package called BalloonSat. A typical RHAB flight uses a standard latex weather balloon, lasts around 2 to 3 hours, and reaches 25 to 35 kilometers in altitude. A typical RHAB flight uses a standard latex weather balloon. Experiments with zero pressure balloons, super pressure balloons, and valved latex balloons have extended flight times to more than 24 hours. A zero pressure flight by the Spirit of Knoxville balloon program in March 2008 lasted over 40 hours and landed off the coast of Ireland, over 5,400 kilometers from its launch point. On December 11, 2011, the California Near Space Project Flight number CNSP-11 with a call sign K6RPT-11 launched a record-breaking flight traveling 6,236 miles from San Jose, California to a splashdown in the Mediterranean Sea. The flight lasted 57 hours and 2 minutes, became the first successful U.S. transcontinental and the first successful transatlantic amateur radio high-altitude balloon. Since that time, a number of flights have circumnavigated the Earth using superpressure plastic film balloons. Each year in the United States, the Great Plains Super Launch, GPSL, hosts a large gathering of RHAB groups.